Hi, this talk will be about what machine learning can and can't do for security. So my name is Wendy Edwards. Let me start by introducing myself. I'm from Urbana, Illinois, which is about 200 kilometers south of Chicago. It is probably most famous as the birthplace of HAL 9000 in 2001. So I work in my day job as a software developer. I'm part of the NASA Datanauts, which is what gave me an interest in data science and machine learning. And I also got to participate in the 2017 SANS Women's Academy. And on Twitter, I'm Wayward710, and my pronouns are she and her. So what are we going to talk about? Let's start with terminology and concepts, and we'll have some examples, and we'll also talk about the limitations of machine learning. So first, probably a lot of you have heard of artificial intelligence, machine learning, and deep learning, and they're essentially kind of nested within each other. AI is the broadest category, then machine learning, and then deep learning. So basically, artificial intelligence. If you recall, since I'm from Urbana, which is the birthplace of HAL 9000, here is a picture of HAL 9000. And artificial intelligence, which would include HAL, would be the branch of computer science that basically attempts to emulate human intelligence. And slightly more narrowly defined, we get machine learning. So machine learning is really actually a lot of math. So you can have, and it looks for patterns and inferences, and you can have something called you can have things called supervised and unsupervised learning. Those are the main categories. And so supervised learning, probably anybody in stats may have heard about prior probability called Bayesian modeling, and that is heavily used by supervised learning. And with unsupervised learning, you're basically drawing abstractions from unlabeled data sets. So for example, with supervised learning, you tend to have labeled data sets, which means you have the answers. Unsupervised learning, you don't have the data sets, you don't have the answers, the data sets are not necessarily labeled. And you can draw abstractions through these unlabeled data sets. So of course, one challenge with unsupervised learning could be making sure that you have it right. And then we'll talk about we'll talk about deep learning, which also use the concept of neural networking. So neural networks are actually not a new thing. They were invented in 1942. And so they're basically modeled on the whole idea of layers of neurons. So they're modeled after the human brain. So the layers are made out of nodes. And so the nodes is basically just where computation happens, which is kind of how a neuron works. And essentially it fires when it encounters sufficient stimuli. So the node combines input from data with a set of coefficients or weights that either amplify or dampen that input. So it's like, do you want more of this input or less of that input? And so the algorithm, by going through this process, is trying to learn what will get the kind of what will bring you the closest to the right answer. And here we have a picture of a neural network. So we've got, in this case, we have it's what's called a feed-forward neural network. So you have a input layer. Then in this case you have one hidden layer with 4 neurons, but you could have more or less neurons or more or less hidden layers, and you have an output layer. So that is essentially just what they're talking about. And now we're going to look at some videos showing neural networks. Let's see. So you can kind of see, I hope the animation works. You can kind of see it's gradually getting better and better. Because you're talking about the test loss and training loss, and you want those losses to be as small as possible. But you kind of see it's actually just trying to accurately categorize the dots in the picture. You can see it's getting closer and closer. This is basically the TensorFlow program, which anybody can use. It's just a very interesting way to see neural networks in action. Let's see. When you talk about neural networks, you're often talk about tweaking parameters, and that means you might adjust your inputs, you might adjust your layers to have more or less. And so here, let's see what happens if we tweak it by just adjusting the input a little bit. So by doing that, we actually added, we stayed with only one hidden layer for neural networks. We added more features, which are more inputs. And if you watched it really closely, you could see it was very accurate, but it worked a lot more quickly than the previous one. And that could be actually very significant, like when you have big data. And then here we're actually going to look at just a slightly different kind of pattern. And then actually that, if I recall correctly, works a lot more quickly if you have fewer input layers. But that is just a neural network in action, and you can kind of see from the weights of the line which inputs are weighted higher or which inputs are weighted lower. So essentially, deep learning, when we talk about it could also be called stacked neural networks. So we got a network composed of several layers. Big data is a very big challenge. One thing that's helped with neural networks is advancements in GPU processing. GPU processing is a graphical processing unit, and that's often used in basically big computing. So it's not a silver bullet so it needs an extensively labeled data set, and that is a lot easier to say than do. And but if you can get that, if you could get such a thing, there are a whole lot of things you can do with it. You can use computer vision, speech recognition, natural language processing, machine translation. I don't know if you've ever used like Google Translate or DeepL.com, but those are machine learning. As for security, it's also can also detect anomalies in user and network elements, and that's going to be very important. So basically, for to use machine learning, what do you do with the data? So with data selection and sampling, you're deciding, okay, so you've got a data set, like let's say you've got a PCAP file, you've got something. So what information in this thing do you care about? What do you want to represent? And that's often called your feature set. And most machine learning algorithms, you're going to need to encode the data in some kind of mathematical fashion, like just dumping the raw data usually is not going to work. And then there's normalization, like so normalization, essentially you're transforming values to a range in between 0 and 1. And this is just some things you do to get your data ready to plug into a machine learning algorithm. And then this would be an example of normalization, like you're looking at the number of requests per second and your CPU utilization percentage. And that could tell you, like, if you're getting hammered by a DDoS attack, is a Bitcoin miner gracing your server with his presence? Is something wrong going on? So in here, the request per second feature have a range 10 times larger than those of the CPU percentage feature. And so if we didn't normalize those values, the distance calculation would be really skewed. And so we just we basically address this by normalizing both features to the 0 to 1 range, which is pretty simple math. So essentially, one big thing in machine learning is pattern recognition. So you're trying to discover explicit or latent characteristics hidden in the data. A thing about that is that one thing about that is that you can use an algorithm to recognize other forms of the data that have the same characteristics. Like, for example, botnets or command and control channels. You very often see similar behavior. You also see like similar patterns, say, in malware. So essentially, clustering. Clustering, the whole idea behind clustering is that bad things happen together. So with clustering, you want to find, how do you group things into clusters? And you want to group things into clusters so that they're more similar to other things in the to things in the same cluster than they are to other things. And there are different techniques you could use. K-means and DB-scan are two big ones. DB-scan, the advantage of DB-scan is that you don't have to start with a preset number of clusters. So let's talk about a clustering example. So this is good. I just put the URL. I'll post the slides. This is where they're clustering incidents together. They actually, I believe, incorporated this into Splunk, so that you could recognize similar instances and keep track of responses, so you could respond in a similar manner. So a lot of time your stock, you're going to have a lot of these disparate inputs coming from different sources. So you'll get all your sources you'll collect, and then this will allow them to this will basically group them into incidents. So an incident is basically a collection of events happening on the same machine at the same time. They may have the same root cause. And so basically you can find these similar incidents, maybe not on the same machine, maybe across your network. That could save the SOC analyst a whole lot of time, because the SOC analysts sometimes often get to spend their time doing a lot of very tedious stuff. So clustering takeaways, you could apply it to a lot of different kinds of data. You do need some statistical validation, and it's very useful when you have a whole lot of data and that you need to find a way to sift through more efficiently. So that is clustering. Let's see, classification. So classification is a little bit differently, because classifications, you've got these predefined class, and you're trying to figure out what the odds are that a sample will be part of this class. And classification is an example of supervised learning, which means you have to start with a pre-labeled data set. And one point is that a sample can belong to multiple classes at the same time. Like, for example, a mango could be part of fruit, yellow, tropical, whatever. And so for an example of classification, one really big, very common classification problem related to security is classifying email as spam or benign, or possibly phishing. Sometimes phishing gets its own classification. So let's talk just some examples that you might do classification and security. You might look for a botnet, because there's just a whole lot of commonalities with that. And then this is basically what a Microsoft study did. They basically they issued a bunch of set HTTP requests to these servers, and they were looking for a very specific set of bot software. To be honest, it wasn't catching any kind of bot. It was catching a kind with a very common bot-related control panel that used WordPress. And so they were querying it, and then they were creating a using a decision tree model. So for example, like they were sending requests to paths that were kind of consistent with known sketchy sites. And then this, for example, might be what a decision tree could look like if you were trying to categorize an unknown website as a botnet command and control site, or whether not. Like you could say, do you have a whole lot of daily visitors? If yes, it's probably not. Has it made your Alexa top site list? If yes, probably not. Well, but maybe it's not getting many visitors, and your URLs auto-generated. That's bad. It's not on your list, and there's an existing threat intel report on it. That's not good either. That's probably a bot, or that's probably a botnet. Just classification takeaways. So classification again is a supervised learning model. There's 4 phases of it: training, validation, testing, and deployment. So a lot of times with classification, you have to break your data into training and testing data. And one thing with classifiers is that it's not necessarily an absolute oracle. It's not telling you that it definitely is or it's definitely not. It's telling you how likely it is that something belongs to a particular category. Like, so for example, like in your email, you know how like benign emails sometimes get caught in your spam filter, and spam sometimes gets through. That's an example of it not being perfect. So another example, like finding malicious PowerShell scripts. So one of the things that people with PowerShell, the attackers using PowerShell like to do is obfuscate their scripts. Like, for example, any idea what this means? Yeah, me neither. So what they did was they took a whole lot of PowerShell scripts, and they used something called, and this is a very interesting example of machine learning uses natural language processing. So there's all these techniques in NLP. It could extract meaning out of it could attempt to extract meaning out of words, and so they used a well-known one called word-to-vec algorithm. And they were able to actually extract these tokens and represent them in a way that showed the context. And this is just the graphic is just an example of some clusters they found doing this way. So so what they basically did was they had a very large set of training scripts that were already labeled clean or malicious, and basically the project worked very well. It did really well with recognizing aliases, which are pretty commonly used in PowerShell. It was pretty successful. So another thing you're doing is anomaly detection. So essentially, you got to think about what represents normal. So what is normal? What describes your data set could be anything. It could be like your network logs, your logs, your network flow, whatever. And then if something is happening that's outside normal, that's considered outliers. And so a lot of times, unusual is not necessarily bad, but it often is. It's like, so it often might suggest fraud or something like that. So even an intrusion detection system, or also like an IDS, what do you want? You want low false positives and false negatives. Like a false positive will waste your SOC analyst time. A false negative, you'll miss a threat. You want a reasonable learning curve. You want something that can kind of keep up because security changes constantly. And you probably will have only a limited amount of resources. And then explainable alerts, like for example, if you get an alert, you don't want to like disable somebody's account without knowing why. And then these are just some things you would look for in a host intrusion detection system. Your processes. Do you have a sketchy new user account? Do you have unusual kernel modules loaded? Are you looking up? I don't know. Are you looking up sites that are known bad? Doing DNS lookups on sites that are problem? Unusual network connection, or have there been unexplained changes made to your registry? But just look for that kind of thing. There's a pretty useful tool for host intrusion detection called OS Query. So I mean, it can measure reliability and compliance, but it's often used for intrusion detection. So for example, like you can schedule it, you can populate tables to be queried later. One limitation is it is not built to operate in an untrusted environment. And it does not have any built-in orchestration, but it can work with Chef, Ansible, Puppet, whatever that. So network intrusion detection. Okay, so you've got a compromised host. it's probably going to need to initiate communication somehow, because a lot of times, like a firewall is not going to let you go in and make and establish a connection with that host. So some examples that are like your botnets, APT, your adware, your spyware. You've got a number of tools you can use. TCP dump basically will capture all your network traffic. Snort is a rules-based engine. Zeek, which is all formerly known as ROS, supports deep packet inspection. That's kind of got its own programming language. It's traditionally it's used signatures, but that can be kind of a limitation. For example, like when you're dealing with a 0-day or something that does not have a signature. And then these would be some of the things you would look for in web application intrusion detection. Your basically unusual IP addresses, like you've got maybe like a website that's just local, and you're suddenly getting like a lot of traffic from China and Russia or Iran. Why? Basically, if you're getting really strange URL entities, they may be trying to fuzz it. If they're using strange characters, they may be looking for vulnerabilities or other things could suggest SQL injection. User agent patterns, like for example, if you're doing automated access, if you're using curl or something, you don't set your user agent, it won't show one. And malware analysis, that's kind of that's basically group by family, and you've got a couple of ways you can analyze it. Your static, it's traditionally been identified by signature matching, but that won't catch your 0 days. Typically, a static analysis is when you look at the code, maybe you decompile it. Your dynamic analysis is when you run it in a sandbox. And then these would just be some of the things you would see in Android malware. Your strings, API calls, network. Like for example, you might see references to system binaries, server addresses, checks to see if you're running an emulated environment. Like if you've got malware, maybe they want to know if you're running it in a sandbox. And again, like we talked about in a previous example, obfuscation. And I've got to show my Gen Xiness. I don't know if anybody recognizes this guy, but this is Bob Seger and the Silver Bullet Band. So basically, it's no silver bullet. As you talked about before, the explainability, like do you know why it is or why it's giving an alert? There's a whole lot of human knowledge to represent. There's problems called overfitting and underfitting. Underfitting is like when it doesn't fit your data very well, period. Overfitting is like, for example, when it matches your training data too well, but not your real world data. Garbage in, garbage out, which means you start with bad data, or if your AI system is being attacked, which it can be, like sometimes directing a bunch of crap at a machine learning system is a form of attack. So basically, your takeaway, you've got the potential to automate some tasks and increase efficiency. So the ability to look for anomaly detection or stuff that's going on strange is very useful for 0 days or APDs or stuff that does not have signatures established. Risk of error, one example I feel like we all saw was Facebook tried to automate some of its content management, and you saw it doing some, and I think a lot of us saw it doing some really strange things. So there's always a risk of error, and I think we will always need competent security professionals. This isn't going to replace us. And then these are just some examples of machine learning software you could use. And I'm going to give some credits to my sources and list some additional resources. And thank you so much for your time.